All right, so hello everyone again, and welcome back to CSE 101 Intro to Programming. So a couple of things that I want to talk about. So today what we're going to be discussing as far as the lecture is concerned is we're going to be doing repetition, so loops, while loops, for loops, do while loops, these kinds of things, okay? How can we make a code repeat itself over and over again until we're done, until we're ready to move on. But first, what I wanted to talk about was, so there have been a couple of questions about the assignment that was posted, and there was something. Oh, there was something else I wanted to say as well. So let me go ahead and show this the assignment text here. So. So as of right now, we haven't talked about a lot of the stuff. There's some stuff in here in this assignment that we have talked about, such as how to make variables, how to get input from users, and stuff like that. So so that you should be able to do. But a lot of this assignment, we're going to give you the tools for that today and next week. So for now, read through it, kind of get an idea of what kind of things we'll be looking forward to. And get an idea of how you might want to do this. But the main thing I wanted to point out that there's been a question about. All right, so there will be a quiz based on this assignment. It will be given on Microsoft Teams in the forums on December 1st. That's Tuesday. That's the Tuesday after the assignment is due. So the assignment is due midnight Sunday night. You will have a quiz given on Tuesday at 12:30. So based on the result of that quiz, it will be used in the calculation of your grade on this assignment. So if you don't submit the quiz, automatically your score on the assignment will be 0. So you need to make sure to submit that quiz. I put that quiz at that specific time because no one should have a class. That's during the break time between classes. So no one should have a class at that time. It's not going to be a very difficult quiz. It shouldn't take you very, very long if you've done the assignment yourself. If you've not done the assignment yourself, the quiz would be probably quite difficult. But if you've done the assignment, then the quiz will be pretty easy. It shouldn't take you very long, maybe 5-10 minutes, something like that. Okay, so you will submit the quiz on Tuesday. The deadline for that quiz will be within that hour. You won't be given a full hour to do that quiz because like I said, it should be pretty simple and straightforward. All right, it's during that break time. And for anybody who's a second-year student, you also don't have any classes that morning at all. So you can sleep till 12:15 if you want that day, and then take the quiz after you wake up. All right, so that should cover that. Like I said, I won't go too much in depth. Oh, one thing I also want to point out: make sure you click the turn-in button. Some of you contacted us in the hours after the final deadline to say, oh, I did this, I uploaded it days and days ago, but I forgot to click the turn-in button. So we are coming up with a solution for those students in that situation. This time you guys should have learned now, and so there will be no we'll strictly enforce the late policy for this assignment and any assignments going forward. Okay. One other thing, as far as contacting us is concerned, I want to make sure I bring to your attention again that if you if you contact myself or Taha Hoja through email, make sure that you type in the subject line of the email CSE 101 and then some idea of what it is that you're wanting to ask about in the subject line. This is not the only course that I'm teaching. This is not the only course that Taha Hoja is dealing with. So we'd like to be able to keep an idea of what class you're talking about. Same thing with if you try to use like the chat feature here in Microsoft Teams. A few of you have sent me a chat message, and I don't know what class you're talking about. Sometimes you're asking, oh, can we have an extension on the assignment, or I don't understand this part of the assignment, and I don't know which class you're talking about. So so make sure that you indicate what course it is, CSE 101, if you're talking about this course, when you contact us with any questions, okay? I don't believe so, the Alpair. If there's any typos that you guys find, like on the last assignment, there were a few errors in the assignment description, some confusing things, some, again, typographical errors that I made. If you find any of those that I feel are where an update to the PDF is necessary, then I will do that. But if I update the PDF just like I did with this one, where I made a note about the quiz, because originally it said the quiz would be in lab, but then we realized that many of you are actually you can't be in lab because you have a class at that time, and there's all those issues with that. So so we put the quiz outside of lab. So I felt that that required an update to the PDF. So I went ahead and made it and uploaded a new one. But just like I did with this one, I made a point to comment on the assignment to let you know that, and I believe you should all, if you have notifications turned on, you should be getting notifications that I wrote a note on the assignment. So if there's an update to the PDF, I will make sure to make a note on the message board part of the assignment to let you know that I made an update. Okay, but I don't perceive any future updates to this PDF, but every time I make a first draft of these and send it out to you guys, I always think I'm done and I won't make any more updates, and then somebody finds an error or there's something that needs to be changed. So it happens. All right, but I think it's done as is, and so you guys have something like 3 weeks to do this in. So till the 29th of November, what is that? That's 17 days. Okay, it's like 2.5 weeks. All right, so let's go ahead and get into it. Let's go ahead and get into giving you the tool that you need, one of the tools that you will need to be able to do this assignment, okay? All right, so just like always, what my plan is to have 2 hours about of lecture time where we go through slides with a break in the middle, and then that last hour we will strictly go through examples, okay? All right, so so we're going to talk about repetition, like I said. So these are the lecture slides. You should have access to all of these. You should have access to all of these on the class materials folder. Okay, and then sometime late this week or next, I will upload the next set of slides for your to you have access to that are about methods. All right, so normally what would happen here is, I'd have this nice graphic here where it would show this fun animation. So it would be like this, sometimes, where as I would click, the new message would come up. Like, sometimes we want programs to do the same thing multiple times, like a copy and a paste in a text document. So we copy and then paste, and then same thing. Sometimes we want programs to do the same thing multiple times, similar to a copy, paste in a text document. So how do we do that? Now, we could just write the same line of code multiple times, just like I've done here, where I wrote this, then I copied it and pasted it, and I copied it and pasted it again. But what if we wanted to display a message like "Welcome to Java" 100 times? Well, it would be kind of really time-consuming and annoying to have to write the same statement, print line, system out, print line, welcome to Java 100 times, right? So we could do that. We could do this, we could do system.out print line 100 times, or what programming languages give us access to is this neat thing called a loop. So in this example, what we do is we have this variable called count. It's like, how many times have I done this, okay? So count is 0. We set it to its initial value. And then we check. So this is like an if statement. So this is very similar to an if statement, but the difference is that instead of just, if this is true, do this, otherwise move on, now it's, if this is true, do this, then go back and check again. Is it still true? Do it again. Is it still true? Do it again. Is it still true? Do it again. And do this over and over again until it is false. When this is false, then we move on. Okay, so we will see as we move along through here. We'll watch through this one. I think this one comes up in more detail here in a moment. All right. So these are some of the objectives. I'm not going to go through all that. You can read that if you want to on your own time. Okay, but this is just like, looks very similar to an if statement, right? We have a decision. An if statement was a decision where if true, we did one thing. If false, we either did something else or we moved on. But now, instead, after we do what's inside of the loop, right, we go back and we check again. Right? So check, is it true? If it's true, do this, go back. Keep doing that over and over and over again until it's false. Once it's false, we move on. So here in this example about the welcome to Java 100 times, count is less than 100 is our check, is our decision. Is it true? We print welcome to Java. We add one to count. This is very important. This is how we eventually get the loop to end. If we don't have count plus plus, we will end up in something we'll read about here in a few slides called an infinite loop, where if this condition is never false, if it's always true, then we'll just keep doing this over and over and over again forever, because it'll never be false and we'll never get out of the loop. Okay. All right. So like I said, we would look at more detail about this one. So let's just, instead of doing 100 times, let's look at 2 times. Okay, because it'll be a lot shorter. 100 times, and we'd end up with like a couple of hundred slides to look at here, and we don't want that. All right. So we initialize count to 0. We check, is count less than 2? And the answer is yes. So we go ahead and go inside of the loop. We print our message, welcome to Java. We add 1 to count. Count is now 1. We go back. Is 1 less than 2? Yes, it's still true. So we do it again. We print, welcome to Java. We add 1 to count. It is now 2. We go back and check. Is 2 less than 2? And I know you want to say it is. You want to say, yeah, it's not greater than 2 yet. But it's not true. It's false because 2 is not less than 2. Okay? It doesn't say less than or equal here. It says, is it less than, strictly less than. Okay? So is count less than 2? Well, count is 2 now, so no, this is false. So we break out and we're done with our loop. Now, a couple of things I want to point out here about this. A couple of things I want to point out here is notice that count never gets displayed and it never gets used for anything other than controlling the loop. There's a special word for what count is in this. We call this an iterator. Okay, it'll show up here in a minute. I don't want to write it here because it'll show up. All right, but it's an iterator. It is a variable that its sole purpose is to control how many times the loop executes. We don't display it. We don't use it outside of controlling the loop. All right. Now we could, suppose we wanted to say, welcome to Java, and then we also wanted to say has been printed X times, has been printed however many times so far. Well, we might then add that into this line. Might say, has been printed, and then we could do plus count times, something like this, and then we can use count as part of it, And I will let you know in the assignment, the iterator that I used when I wrote the code for the assignment to show you the examples does use the iterator inside of the loop, does use it to display stuff, okay? But its main purpose is not to being displayed. Its main purpose is for controlling how many times the loop executes. Move on to that. Okay. All right. So we may look at this example, repeat addition quiz. There's a number of good examples in there, by the way. Okay, we won't look at all of them because I want to look at some examples, but I also want to do two examples with you that are not included in here that I've put up into the chapter 5 folder. Okay, so we may look at this one. I know that we are going to look at this one because I want you guys to help me with some of the stuff in this one. Okay, but basically, so let me go back. Repeat addition quiz. Remember the previous chapter there was an addition quiz where it generated two random numbers. It said, it asked the user for an answer to what is A plus B. If they were correct, the program said, yay, you're right. And if they were wrong, it said, no, you're not right. Here, repeat addition quiz, we might want to let the user enter answers until they get it correct. Okay. And one thing we might be able to do in that is be able to count how many times they gave the wrong answer. Right. And then that way we could help them know if they're getting better at giving the correct answer for addition quizzes and stuff. So as we keep track of what maybe their average number of wrong answers are. Okay. We could also have a problem involving guessing numbers where if where we create a program that generates a random number between 0 and 100 that includes both of those, 0 and 100. The program keeps asking for a user, asking the number from the user over and over again until they give the right random number. Okay. One thing we can tell them in each time through the loop is whether or not what they've entered is too high or too low. So we're not just having them constantly just guessing randomly. We could have them say, like, if they guess 50, oh, that number's too high. So then they know I don't want to guess higher than 50. I want to guess lower than from then on. Okay. Do we have a question? Yeah, we'll get to that. We'll get to for loops in just a moment. Okay. There's three types of loops that we'll talk about: while, do while, and for. Okay. Subtraction quiz, similar to addition quiz, we could generate specific numbers of questions. So we generate here in this example, it says we'll generate 5 questions. So we could create a specific number, like maybe I want a 10 question quiz or a 20 question quiz. And I want to be able to change that value, and then the program creates those particular numbers of questions for that quiz. Okay. So one thing that when we talked about this example up here with the printing Java a specific number of times, so that's a specific type of loop that was it Berkai? Yeah, Berkai said. Asked about the for loop. Okay, so what we'll see towards the end of this lecture, towards the end of this set of slides, is certain types of loops are better than others for certain types of problems. Okay, now the idea of ending a loop with a sentinel value, this would be if the user wants to exit the program and we don't know when that's going to happen. Then that would be a sentinel value. The exit, whatever the exit condition is, would be the sentinel value. So, for example, I often use banking, and especially using your debit card at an ATM as an example, because it's something that many of us have done. And it's also a very, very good example of a computer program that uses a lot of our tools here. So when you walk up to the ATM, you put your card in, you type in your PIN, and it gets you into your account. Now at that point, we're starting a loop, right? Because what's going to happen is it's going to say, what do you want to do? Do you want to add money, para yatama? Do you want to get money out, para checkmate? What do you want to pay it? Make a payment? What is it you want to do? Well, once you do that, for some things, once you do that, like maybe once I add more money to my account through the ATM, it doesn't just end, give them that card back and say go away. What happens is it returns to the main menu, right? And it waits, it keeps going back to the main menu. I add money, I make a payment, I do some other things, and I keep doing these things through the loop until I'm done and until I say I want to exit, or I think, what is it, cart iade, right? When I press that, that is the sentinel value. That's the value that's saying user wants to exit the loop, okay? So in this way, a sentinel value is something where we don't know. Sentinel values are where we don't know when the user is going to be done and wants to exit. So we just wait till they tell us. Okay? All right. So this is the idea of the number of times the loop is executed. We don't know that in advance. We don't know if it's going to run 100 times. We don't know if it's going to run 2 times. We just know that eventually the user is going to want to get out of the loop, and they are going to tell us when that happens. Okay. All right. Now, we'll look at this particular example during the examples time, because I do want a similar example that's like it, because I do want to look into this. All right. Floating point values for equality checking in a loop is we don't do that. The reason why is because floating point values are just approximations. They're about, we looked at an example like this, right, where we said 1 minus 0.1, then that minus 0.1, and that minus 0.1, and it eventually got down to like 0.5000003 or something, right? So it wasn't exactly 0.5. So if we check for that equality, if I were to say, is it equal to 0, and the value was something like 0.00000000001, right? Well, I might look at that and say, well, yeah, it's practically 0. But the computer will say, but it's not exactly 0. Right? And so it won't end the loop, and it will keep going over and over again, because it's never going to be exactly 0. And this would be what we would call an infinite loop in this example. It'll be something else if it's even for something like if we were to say while, come on, even if we were to say greater than 0, while item is greater than 0, this could still be a problem, because we could end up with 0.00001, where we would expect the loop to exit, but it actually doesn't. Okay, so this would still be a problem. And I'll show you a way to deal with that during our examples time. I want to show it to you because it's a little bit hard to explain without showing it. Okay? All right. Before we get to for loops, though, I do want to talk about one other type of loop. So the one that we've been talking about so far was what we call a pre-test loop. It is the while loop, and the for loop that we'll talk about in a moment is a pre-test loop. What it means is that in a pre-test loop, let me go back to show the flowchart. Good. Okay. In a pre-test loop, we check the condition first, then we do the statements of the loop, then we go back to check the condition again. So in a pre-test loop, if the condition were to start off with, we would never do the statements inside of the loop. So this loop will run a minimum of 0 times. Like, it might not run at all. We don't know for sure if it will ever go inside of this loop. Okay. Now, this do while loop is what we call a post test loop. What that means is after we do the body, after we execute the inside of the body, then we check the condition to see if it's false. If it's true, we go back and do the statements again. Unlike the pretest loop, the body of this loop will always be executed at least once. We will execute this. We will check, is the condition true? If it's not, we move on. So if it starts out first time at this decision, if it's false, we just move on and don't do anything more. Okay. This is the do while loop with the post test, making sure that this happens at least once. This is oftentimes how menus are done, like at the bank ATM, like example that I told you just a moment ago. The menu will come up for sure every time, right? There will never be a time that I type in my PIN correctly using my card that the menu doesn't come up. Right? The menu will come up. So the menu is this. Then it checks, did the user choose cart iade? Did the user choose to exit? If they did not choose to exit, so user did not choose exit, true. They did not choose to exit, we go back and do more. Yes, they did choose to exit, we move on. Okay, and we return their card and we get out. Okay, so that's the difference between a pre-test and a post-test loop. Okay. So let's go ahead and talk about for loops then, because for loops are an example of a pre-test loop where we do something, we have some initial action, but we check the condition. If it's true, we do the body of the loop, then we go back. Technically, you could see this action after each iteration, this action after the last step here, as part of the body of the loop. In a sense, it is. Okay. Now, one thing that that you commented on here, okay, for doesn't work like while. That's true, not entirely. Now, how do I want to say this? In Java, the way that for loops and while loops work, every while loop can be expressed as a for loop. And for the most part, most for loops can also be done as a while loop instead. Okay. We'll talk about why you might choose one over the other in just a moment. But I do want you to know that basically, notice that this right here, everything except for the initial action, this right here looks exactly like the while loop, doesn't it? It looks exactly like, if I go back to the flow chart, looks almost exactly like this, right? Go back. I wish I could put these side by side. Maybe I can. Yeah, I can. Copy this. That's nice that I can do that. This online education may not be so bad. Okay. Notice that if I think of an initial action being up here, and if I think of this action after iteration being as part of the body, then these are practically the same. Okay. So a while loop could be, you could use a for loop instead. A for loop, you could use a while loop instead. So which one should we use? We'll get to that. Okay. We'll get to that in just a moment. Okay. All right, so let's take a look Let's take a look at what a for loop looks like. Same thing with the welcome to Java stuff, okay? With printing that out as an n numbers of times. So first we declare our variable I. Then we'll set the value. I is now 0. Remember, I is like count from earlier. It doesn't matter what we name it. Remember, the compiler doesn't care. Do we name it count? Do we name it I? It doesn't really matter. All right. So we set it to 0. I is less than 2. Yes, 0 is less than 2. We print welcome to Java. I don't know why the font color went weird on this one. But we print welcome to Java. We execute the plus plus, just like that count plus plus plus. Notice that it shows up here now. Okay. For loop syntax has this initial condition, semicolon, Boolean check condition, a loop check condition, semicolon, then some other statement, one or more statements here. I say one or more. You can have more than one statement here and more than one statement here. You can only have one Boolean expression here. Okay. So we add 1 to I. Notice we did not put it down in here. We put it here instead because that's what we want to make sure is the last thing that happens before we go back and check the loop condition again. Which now, since I is 1, it is less than 2, so it's still true. We print welcome to Java a second time. We add 1 to I. Now false because 2 is not less than 2. And we break out of the loop. Okay. Now there are some key differences between the for loop and the while loop. One is that in the while loop, so if I look back at the while loop, slide 34, if I look back at this while loop, notice that int count was declared as a variable outside of the while loop. What that means is that I can use count later on. So if I wanted to say later on, how many times was this loop executed? I can use that variable outside of the while loop. So I could have some statement down here, you know, print count. The loop was executed count number of times. For the for loop, however, not for this one, because here it was also declared outside, but here, right? Int I was declared inside of the loop. So therefore I can only use I inside of the loop. Okay. This is very important because if I try to use I outside of the loop, it will give me a compiler error because it'll say that variable doesn't exist. All right. In here, notice also that this statement here, this where I add 1 to I, right? It not only does something, but it also changes the value of I. I can do this. This is okay. And notice that also this semicolon on the end. One thing that we talked about with the if statements. If you put a semicolon on the end, the compiler sees the line as a statement. So remember, if you put a semicolon on the end of an if statement, it would still execute the next line, even if the if condition was false, because it would see the semicolon and would say, I'm going to execute the next line anyway. Okay. With loops, it's a little bit different. It sees it as a statement, so it's going to try to run this whole thing until and then it will move on. So if what's inside of here is an infinite loop, like something like while true semicolon, it will never end. Okay. What's some other things I want to say here before I address any? There, I see I'm getting a number of comments. Let's come back to this. Let me go ahead and address the comments that are being made because I want to come back to this, and I want to make sure because I think maybe we've kind of maybe done a little bit more than we should have in the first hour. All right. So so let me go ahead and address the comments and I can get out of there. Okay, and then we can take our break. Okay, let's see. Okay, Tefik, you are talking about. Let me go back and share this again so I can make sure I know what you're talking about. Okay, Tefik, you said, why did we define the I inside of the print? You talking about for the? Are you saying for the for loop? Are you talking about here, like the? Why do we set the value there? Is that what you mean? Yeah. So we don't have to see this. This and this are the same thing. Okay. Normally what we would do is actually the way we would normally do a for loop is we would do that. That's the normal way that we would do a for loop. Since we only want to really have it inside of the for loop, we only want it to be an iterator for the for loop, then we would usually both declare it and initialize it in the same part right there as part of the initial condition. Okay. I hope that answers your question there. Let's see. The I is showing the number of repetitions. Yeah, in this particular situation, yes, the final value of I is going to be 2, which will be the number of times that this loop executed. That's not always the case. Sometimes the final value of our iterator has no correlation, it's not connected to how many times the loop executed. It's not always good, okay? Okay, any changes you made to variables that were defined outside of the loop, any changes you make to those variables, Recep, Samet, which name would you prefer, or does it matter? Any changes you make to variables that are defined outside of the loop stay made even once the loop is done executing. Okay? So like, for example, go back to this one here. So when we exit, so I starts out not declared at all. We make this change to its value to be 0. Then we change it to 1. Then we change it to 2. Then we exit. The final value, if I were to have something like print line I here, it would print out the value 2 because that's the final value by. So that can be the same with multiple variables. Any variable that I change inside of the loop, its final value when the loop is done executing is what its value will be when we get out of the loop. Okay. Numbering. Yeah, we can use int in a while loop. We can use any type of variable. We can use a string. We can use a character. We can use a Boolean as something for in a while loop. Okay. It's just basically, is this condition in a while loop or a for loop? Is this condition true or false? When it's true, I go inside of the loop. When it's false, I exit the loop. So anything. Okay, good question, DJ. Same thing about using the curly braces. Same as the if statement. If you only have one line of code, you don't require these curly braces. So if I were to take these off, this is the same type. This is the same thing. I have made no change functionally to the code at this point. Because there's only one line of code in here, that will be seen as the only thing inside of the for loop. Notice that that would not work though, even though this loop, this for loop, and this loop, this while loop are practically the same. It practically does the same thing, right? It prints the message welcome to Java a specific number of times. But if I were to remove the curly braces here, now I have changed the functionality of this loop. Now what I've done is I made only this line inside of the while loop. And because count is not being changed, this will result in what we call an infinite loop. Because it will keep going. It'll say count is 0, print welcome to Java. Go back, count is still 0, print welcome to Java. Count is still 0, print welcome to Java. Count is still 0, print 0, 0, print 0, print 0, print 0, print. And it'll keep doing that forever and ever, theoretically. In actuality, as we'll see, I will have a couple of examples. I'll have an example of an infinite loop here during the examples time. And you'll see that actually what ends up happening is what we call a stack overflow, and or an overflow of some kind that ends the program because it just can't handle doing anymore because computers are limited. Okay. All right. If there's no other questions, all right, then what we'll do is we'll take our break. I will go ahead and stop the recording here. We'll take our break, and then I'll see you guys in 10 minutes. Okay, 10:30, 10:32, we'll go ahead and start.